Okay, sorry about that, folks. Little home situation I needed to deal with. Okay, so we're back. So it's just the second part of the video over here. My apologies for that. So right here, okay, we want to figure out if this guy is positive or negative. It's not as nasty as you might think. 2 minus sine y, remember sine y is going to oscillate between 1 and -1. That's what the graph of sine does. So 2 minus any number between 1 and -1 is always going to be a positive number, okay? So this right here, always positive, because sine y, I feel siney, oscillates between 1 and -1. That's cool right there. He's going to be positive. And the top, he's always going to be positive too. If you think about cosine x, okay, if you graph y equals cosine x, remember my impersonation. Look, this is what it is from 0 to 2 pi. We'll back it up over here. This is negative 2 pi to 2 pi, but you only want negative pi over 2, which is right here, to pi over 2. This graph is always positive from negative pi over 2 to pi over 2. So this thing right here, always positive. We'll say on negative pi over 2 less than y less than pi over 2. Hopefully you can see my squeeze didn't work right there. So by the way, the top is always positive, the bottom is always positive. Positive divided by a positive is a positive. So the second derivative is actually always going to be positive. And if that's true, the curve is going to be concave up. So we'll say curve is I'll write it out, concave up. Because d squared y over dx squared is going to be greater than 0, okay? So that's a little tricksy right there, and people might be like, well, who the heck, I don't know how to do it. The second you see concavity, take that second derivative. You take that second derivative, you're going to get a point right there, okay? Afterward, this gets tricky. It's not so easy. Part D is also not so easy. I've never seen one like this before, but it's cool. Let y equals f of x be a function defined implicitly by this guy right here, okay? So really, it's a function defined implicitly. I think it should say y equals f of x comma y. No, because we have the y equals f of x. That's okay over there. Don't worry so much about that. But it's just the curve we were dealing with. It tells you it's continuous in the closed interval and differentiable on the open interval. I smell the mean value theorem. And here it is. Use the mean value theorem on the interval 2 to 2.1 to show this inequality. And this is kind of weird. When you see that the mean value theorem, you know what that means, right? It means that if a function is continuous and differentiable, which this one is, there's got to be at least one x value c, such that if you take the derivative and plug it in there, you get the slope of a tangent line, and that's equal to the slope of a secant line, okay, from whatever x value to whatever x value you want, as long as c is in between them, okay? So this is kind of weird. We're just used to this, and you can see here the f of b minus f of a piece. It all comes from this right here, okay? So this is a little filthy. They told you originally that 2/3 was less than or equal to dy over dx, which was less than or equal to 2. So they really told you two different inequalities here. They told you that dy over dx, they told you 2/3 was less than or equal to dy over dx. I'm going to write that over here. 2/3 less than or equal to dy over dx. And then they also told you that dy over dx is less than or equal to 2. So you could write over here that dy over dx is less than or equal to 2. And if you just solve both these inequalities, for f of 2.1 minus f of 2, you're like, what the heck are you talking about here? Well, this is 2/3 less than or equal to that dy over dx, okay? Look, if you put 2 over 2 minus sine y, that's not what they're looking for, okay? This is really this piece, the 2/3 right here. They're telling you that the derivative has to be equal to 2/3 or greater than 2/3, and that means that the slope of the secant line has to equal 2/3 or be greater than 2/3. So that's really your f of 2 minus your, I'll start with f of 2.1, right? That's the way we usually write it, and that's what they want anyway. So that says your f of 2.1 minus, I was just messing everything up here. What am I doing? F of 2.1 minus f of 2 over 2.1 minus 2. Okay, that's just the mean value theorem right there. Here's f prime of c. Here's f of b minus f of a over b minus a. And then you can do it over here. F of 2.1 minus f of 2 over 2.1 minus 2 has to be less than or equal to 2. And now if you just cross multiply, okay, if you cross multiply here, 2.1 minus 2 is equal to what, 0.1, which is really equal to 1/10. Okay, it's what 0.1 is. So 2 times 0.1, you could say is 0.2 or 2/10. That's really going to be, 2 tenths, it's going to be 1/5. Okay, that's when you multiply here. Less than or equal to 3 times this expression, f of 2.1 minus f of 2. Okay, and now if you actually divide by 3 on both sides to solve for this, really multiply by 1/3 on both sides, probably the best way to do it. Okay, now you get 1/15, which should look familiar. Less than or equal to f of 2.1 minus f of 2. And that's actually the first piece over here. You know, over here, once again, this is 1/10. All right, and if you cross multiply here, okay, you know, we'll do this one first. F of 2.1 minus f of 2 times 1 is just f of 2.1 minus f of 2, less than or equal to 2 times 1/10 is equal to 1/5. And if you actually take these guys and you put them together, okay, remember you can just squeeze it together because these are equal right here. You know, therefore, even though there are 3 dots, you get that 1/15 is less than or equal to f of 2.1 minus f of 2, less than or equal to 1/5, okay? Which is pretty filthy, okay? So right now, you might have been like, you know what? I completely gave up on that piece. You know, I can see it. Part C certainly should be able to take that second derivative. Afterward, does get a little frumpy over here. This guy over here, it's not so easy to pick up even 1 point. Even if you write this down, I don't think it's getting you anywhere. So it's not so easy to pick up any points for this right here. It's not so easy to pick up all the points as well. But remember, there's going to be stuff on your AP exam you've never seen before that's difficult. So watch those 2 videos, okay? Try your homework problems. This is Thursday right here. I know you get a lot of APs. I know you have a lot of stuff to focus on, okay? But you got to do these homework problems. Tomorrow you get more homework problems. And over the weekend, there's 12 part 2s. I want you to work on them, okay? You know, I do 6 on Saturday. I do 6 on Sunday. Time yourself. It should be about 15 minutes for each of these. You know, the first problem on your AP exam is going to be 25 minutes instead of 15 minutes, which just means that they're saying it's going to be like the other problems they've given. So really, I consider it's going to be like AP problems we've done with a few more parts, okay? But there could also be some short answer there. Who knows exactly what's going on? But do the best you can. Keep working. If you work, you will succeed, folks. If you don't, you will not. And that's all I have to say about that. Until tomorrow, this is Berto signing off.